My name is Mathieu Caron, and I am the supervisor for the Canadian Space Agency Mission Controllers. The Robotics Refueling Mission, or RM for short, is a demonstration that will enable us to see just how far we can push robotic servicing on orbit. As we have seen with Dextre over the last 4 years, robotic systems can be used to repair the International Space Station. One thing to note, though, is that the components on the International Space Stations were designed to be repaired by robots. They have certain features that make it easy for robots and their operators to interact with those components, to remove them and replace them with new units. Unfortunately, that's not the case for most of the satellites that we'll find on orbit. Satellites were designed for a single use, and they were not designed to be refueled or repaired by robots on orbit. In fact, people have tried to make it as difficult as possible to unscrew the various caps and wires in order to make sure that nothing gets loose during launch. So the point of the RM module was to demonstrate that robotics systems would be able to interact with components that were themselves not designed to be handled robotically, and would be able to safely and complete refueling and repair missions to those robots. So to that effect, NASA put together the Robotics Refueling Mission module, which was launched on the very last shuttle mission. The RM module is located outside on the space station, and the point is to provide Dextre with 4 additional tools that would allow Dextre's hands to be able to interface with the various caps, wires, and surfaces it will encounter on the Robotics Refueling module in order to demonstrate that a robot such as Dextre could do a refueling mission on a real-life satellite. Over the first few missions that we've completed so far with Dextre, we've been able to demonstrate that Dextre could safely unscrew various caps and cut retaining wires that will allow us to eventually show that it can refuel a satellite. We needed to proceed very methodically in order to demonstrate that Dextre could perform these tasks which were beyond its initial design, or so we thought. So now, in the next week of operations, what Dextre will do, it will take all of the tasks it has accomplished so far and integrate them into a full-blown simulated refueling of a satellite. So the Canadarm2 will move Dextre to the vicinity of the RM module, and then it will retrieve the required tools in order to unscrew several caps and cut the wires holding these caps into place before it goes to get a robotically compatible nozzle tool that will be connected to the fuel valve that's been uncovered by Dextre, and NASA controllers will then pump simulated fuel to really demonstrate that one day we'll be able to send robots to satellites and refuel them on orbit. This mission is particularly important because it demonstrates to us that robotic systems can be used in order to repair and refuel satellites. It shows us that we can use the International Space Station as a test bed to further our understanding of robotics and how they can be used to help further space exploration. So we've seen with the space station that robotic systems such as Dextre could be used in order to improve the safety of life on board the space station, because having Dextre perform robotic maintenance allows the astronauts to remain within the relative security of the International Space Station modules. Well, for satellites, right now, if you look at servicing missions for satellites, astronauts, for instance, had to go to repair the Hubble Space Telescope. Fortunately, the Hubble Space Telescope was equipped with grapple fixtures that allow the first Canadarm to grab onto it and bring it into the shuttle payload bay. Most satellites, however, were not designed in order to be refueled on orbit. In fact, the designers of satellites tried to make it as difficult as possible to remove the caps that would allow us to refuel them, because they don't want these various components to come apart or come loose during the launch of the satellites. So as a result, we have to use robots in order to perform those tasks, cut wires, unscrew caps that were not designed to be handled robotically. In fact, it's very difficult for an operator to do so. The advantage, though, is that if you demonstrate that you could send robots to repair or refuel satellites, then you could prolong those lives, so you can have a higher return of investment for various satellites. Not only that, but once a satellite have expended its fuel, once one of its component has failed, essentially when it becomes just a useless piece of machinery on orbit, it also represents a danger to the other satellites, the useful satellites on orbit. So for that reason, it's particularly important to prolong the life of the satellites as much as we can. And before we can try to do those ambitious missions for real-life satellites, then we need to demonstrate that the robotics technology is mature enough that we can attempt those endeavors. And so far, we're quite proud to say that Dextre has been up to the task for everything we've thrown its way.